Welcome to Cartera's how-to video series. This video will discuss how to perform a serial Y alignment in our kinetics analysis software. In this video, we're going to become familiar with how to properly process non-regenerative kinetics experiments or capture kinetics experiments. The purpose of this is to demonstrate a serial Y alignment processing procedure that allows us to properly address the fact that when we have slow off rates, our antigen or analyte is building up on our ligand surface. I've gone ahead and pre-processed some of this file to make it easy to understand. What we see is that first, ligand is captured on our sensor chip surface, and then we inject a series of buffer blanks to achieve a more stable surface, followed by a series of sequential analyte injections, starting from a low concentration and ending with a high concentration. The first step will be to identify the buffer blanks by clicking and dragging to select multiple rows, and then right-clicking and assigning these as blanks. Next, we want to ensure all our analyte injections are identified under the same group. We're now ready to start the processing procedure. I'm going to select the Analyte Processing tab. And the first thing we're going to do is perform a reference subtraction. We'll navigate to the Reference tab, and we'll apply the referencing. The next step is to perform a blank subtraction. I'll select the Blank tab. We're going to ensure that we're using the leading buffer blank, and we'll apply the blanking. Next, we're going to go to the Y Alignment tab. We're going to select the serial view, and we're going to place the bounds, the slider bars, during the baseline section of the first analyte injection. And then we will apply the Y alignment. Next, we want to select the Overlay tab. Again, placing the slider bars during the baseline section, we're going to then apply a baseline correction Y offset. This is to correct two common processing artifacts. It will lift up any signals that started below zero up to zero. It will also adjust any cycles which start above the end of the previous and bring those into alignment. And the final step in order to properly process this non-regenerative kinetics data is to crop off the baseline. To do this, we're going to place the start bar right at the association inflection point. We're going to place the stop bar or bound right at the end of the dissociation. And we will apply the crop. Now we're ready to fit the data. We'll select the Kinetics tab, Kinetics Analysis, and we want to ensure that the float T0 is selected in order to properly fit the non-regenerative kinetics data. This data set has some bulk shift, so I will also include the bulk shift parameter. Make sure the green bar is all the way to the left, and the red bar is at the first data point after the start of dissociation. We're now ready to fit the off rate and on rate. As a quick recap, in order to perform a serial Y alignment for non-regenerative kinetics data, we're going to first perform a reference subtraction, followed by a blank subtraction. Then we're going to do a serial Y alignment, placing the bounds during the baseline section of the first analyte injection. Next, we're going to perform a baseline correction with the overlay view, also known as the Y offset. And finally, we crop the data, placing the start and stop bounds at the association start time and the dissociation end time. Thank you for watching this how-to video from Cartera. For more information, please visit us at www.cartera-bio.com.